Hello, everyone. Today we are going to talk about fluvial landforms or landforms that are shaped by water. But before we can really understand what water does to the landscape, we need to talk about something that works hand in hand with it, mass wasting. And no, mass wasting is not a description of my weight loss journey. Mass wasting is an external earth process where earth, and rock, and soil move downhill under the influence of gravity. Water, slope, earthquakes, and vegetation all play major roles in triggering these movements. So what is mass wasting anyways? Let's look at two examples. On one side, we see uniform subsoil. Everything looks pretty similar. On the other side, the subsoil is layered with different rocks and soil types stacked on top of each other, but then uplifted at an angle. On the left, the land has slowly shifted downward and outward. This can be caused by groundwater movement, surface water, and natural settling of the sediments. This type of movement is called slumping. On the right, we can see a landslide where one of the sublayers was weakened and failed, and the material above it suddenly moved down slope. Both of these are examples of mass wasting, but they behave differently based on what is underneath the sublayers of the soil. Another type of mass wasting is a debris flow, and this occurs when the water from mountaintops starts to melt. So if you can imagine two mountains with a river cutting between them, in the spring the snow melts rapidly, saturating the soil. That water picks up loose rock, mud, and sediment and carries it down slope and deposits it at the edge of a stream channel or at the base of the valley where the stream exits the mountains. That fast moving mixture of water and debris is a debris flow, and yes, they can be incredibly destructive. What causes mass wasting or triggers a mass wasting event? Several factors are included, including water, which we have talked about, that can either be rainfall or groundwater, steep slopes, like in mountains, vegetation removal, and earthquakes. Water and earthquakes are especially powerful triggers. For example, in the 1990s near Granite Falls, Minnesota, an earthquake occurred. About 10 to 20 years later, a large section of land slumped. Unfortunately, it slumped right along a state highway. Engineers later discovered the slump overlapped a fault line that was previously undiscovered, meaning that it would continue to move in the future. So, the state highway officials decided to move the state highway to a different place where it wouldn't be as destructive. That is an example of geology meeting infrastructure in an inconvenient way and policymakers adapting. Angle of repose when slopes fail. Slopes between about 25 to 40 degrees can define what we call the angle of repose. Below this angle, so 20, 15, 20 degrees, are generally stable slopes. Above it, so 45, 50 degrees, are more likely to fail. Stability also depends, so 15, 25 to 40 degrees is a huge difference, so it depends on their soil type, rock layers, water content, vegetation. Something like solid bedrock can remain stable at steeper angles, so for example, mountains, and that's why river valleys often have steep walls made out of bedrock. On the other hand, the 25-degree angle is a little bit more like soil. So, for example, the river valleys in the Mississippi River are going to be a much lower slope. Unfortunately, humans love to build in river valleys, and they're building um, houses on very steep angles. So that is 40-degree angles, and it's soils rather than bedrock. And so because of that, we end up having a little bit of instability along those cities that are built on river valley banks. And this is why engineering and geology and hydrology matter so much in urban planning. Trees matter more than you think. Vegetation plays a huge role in slope stability. Tap roots for trees are as long as or as tall as the trees themselves. And so they anchor to the soil, reducing erosion and regulating groundwater by allowing moisture to come out of the trees during times of drought and to absorb water during times of flooding. When trees are removed, either naturally or by humans, the slope becomes far more vulnerable to mass wasting events like landslides, slumps, and debris flows. The hydrologic cycle, why water changes everything. Because water plays such a big role in mass wasting, we really need to understand the hydrologic cycle. Water falls to the earth as precipitation. Then it moves across the land through streams and rivers. It sometimes collects on the land in lakes, and sometimes it ends up in the ocean. From the rivers, the lakes, and the ocean, it evaporates back up to the atmosphere. In Minnesota, nearly all precipitation ends up in the Mississippi River drainage basin, which eventually flows down to the Gulf by New Orleans. And yes, when I was a kid, we used to joke that if you peed on one side of the Continental Divide, it went down to the Gulf, and if you peed on the other side of the Continental Divide, it went to Canada. The closest continental divide to southwest Minnesota is up by Morris, Minnesota, and the Red River flows north into the Hudson drainage basin, while the Minnesota River uh, flows down into the Mississippi drainage basin. When we talk about stream flow, we are not talking about your urinary health. We are talking about how fast or slow water moves through a river system. In mountain streams, like those in the Black Hills, there are steep gradients, narrow channels, and seasonal discharge. As the water moves out of the Black Hills and onto the prairie, so for example, the Belfour River system, the channels become wider and the gradient is much shallower. And the discharge is more regular as there is regular precipitation on the prairie. And yes, regular discharge sounds like a joke waiting to happen. So we're going to move on. Sediment transport, how rivers carry material. Streams move sediment in three main ways: dissolved, suspended, or bed. The dissolved load are chemicals that are dissolved into the water from the neighboring soils or even brought in from the neighboring groundwater. Suspended load are fine particles in the streams and rivers that make the water look muddy. Bed load are the larger particles that are rolling along the bottom. So during times of heavy discharge, the rocks and particles on the bottom of the stream are going to roll along, but when there's slower discharge and the river is not moving as fast, those rocks stay put. Capacity and competence are very similar. Capacity is how much a sediment in a stream can carry. However, competence is the largest size of particle that can move. Depositional landforms. At the mouth of the Mississippi River, the sediment builds up to form what we call a delta. and it's right outside of New Orleans. As the flooding from the Midwest and the Rockies reaches the delta, more and more sediment piles up around the delta, and it creates a natural levee. However, levees are not just a naturally made landform, they can also be man-made, and they are also subject to flooding. For example, when my 6 times great-grandpa came over from Ireland in 1849, they had just had a flood the previous summer that broke the man-made levees. Humans like living near rivers because it's a source of water and a source of transportation. The Mississippi Delta has been heavily populated since at least the 1700s by European settlers. Flooding has always been a part of the system, and so humans respond by building levees and dams and drainage tiles and diversion channels. All of these are expensive infrastructure, so one of the solutions that people have is to not live on active floodplains. Groundwater. There are 2 points about groundwater. The first is the structure. The water underneath the ground holds up the soil and gives it some substance. As groundwater moves around and dissolves various elements, it can open up caverns or caves underneath the soil. As those caves become bigger and bigger, the soil on top of them starts to sink and we get sinkholes. Likewise, if we have a ton of sinkholes in the same area and all of those caverns are exposed to the elements, we get something called karst topography. Groundwater makes up most of the Earth's fresh water outside of glaciers and ice sheets, and we store it in aquifers. Okay, we don't store it, but the Earth stores it. Some aquifers recharge quickly, like those that are in the upper Midwest around Minnesota, where we have the land of 10,000 lakes. Other aquifers do not recharge quickly, like the Ogallala Aquifer of the Great Plains. This includes all of Nebraska, parts of Kansas, Colorado, Wyoming, South Dakota, and the Oklahoma and Texas panhandles. It doesn't recharge on a human timescale, which effectively makes it a non-renewable resource. When groundwater is pumped out faster than it's replaced, the land sinks or subsides. The San Joaquin Valley in California has been heavily pumped over the last 50 years and has dropped 30 feet because of this. The same thing is expected to happen in the Ogallala region, along with the fact that all of the people that live in towns, the farmers, and the animals that live in that region will lose their source of water. Why does this matter to you? As you decide where to live, or if you ever worked in city planning, or even if you're an elected official, or if you're working for a company that is working on developing land, you need to ask yourself, is this area prone to flooding or landslides? Does this land require a non-renewable aquifer or does it have adequate supply of groundwater? Will I need sump pumps or retaining walls or flood protection? I never thought that studying geology would lead me to these conversations, but as an elected official, as a city council member, I had to oversee water system planning that required engineers that had these conversations to ensure long-term success and clean groundwater for our city. In southwest Minnesota, some communities are currently importing water because their local aquifers are polluted or depleted, and they're actually importing them with water from the Ogallala Aquifer. Some final thoughts for you. This information helps you make smarter personal decisions, understand environmental risks, and think critically about land use and sustainability. And somehow, whether you expect it or not, it might even help you in your career or your community responsibilities. Thanks for sticking with me.